Teacher found that 31 out of 50 students scored over 80 in exam 1, which is over the expected proportion. They expected about 50% to get 80 or above. So, does sufficient evidence exist that the proportion of scores over 80 is greater than... Look, this is what we're trying to test. Is there enough evidence to say that the proportion is greater than 0.5? So, put formally h sub 0 and h sub 1. I actually usually use colon like this. They want us to test whether the proportion is greater than 0.5. So that goes for our alternative. That means the null is that the proportion is equal to the hypothesized value or less than. The null hypothesis, the proportion hasn't changed. Oh, I marked it correct already. The alternative hypothesis is that the proportion is greater than 0.5 because that's what they're trying to test. That's where our alternative hypothesis goes. What's the p-value? Well, we need a z-test statistic, and that's found by taking p hat. And we use z with proportions, and there's a proof out there for why z can be used instead of like using something like t. And it's p 1 minus p over n. So that's the formula for calculating the z-test statistic. Once we have z, we can go to an online calculator and get a p-value from it. Scores over, so we had here, we need a sample proportion. We need to know what p hat is. So there was 31 divided by 50. 31 out of the 50 people. So we got a proportion of 0.62 that scored over a score of 80 on this exam. So 0.62 is our p hat. It's our sample proportion. And the proportion we're testing against is 0.5. And then you divide that by the square root of 0.5 times 1 minus 0.5 over n, where n is the sample size. So this is kind of hard to compute. 0.62 minus 0.5 is 0.12. If you had trouble with algebra, this part can be it can definitely be tough. Okay, so n is 50, by the way. What you need to do is figure out what the square root is equal to. And here, this is a divider, separate part. Okay, this is a previous step. This is the step we're on. I did 0.62 minus 0.5. That makes 0.12. Now inside the parentheses, I'm going to do 0.5, and then 1 minus 0.5 in my head. That's 0.5. So the top is 0.5 times 0.5. And then we need to divide that by n, the sample size. And there's 50 observations. So n is our sample size. So that's what everything is before we take the square root. So now if we take a square root, that's what the denominator is equal to. The square root of 0.005 is 0.0707, etc. So we need to take 0.12 divided by the denominator. Oh, did not paste? Oh, there we go. So I got a z-score of 1.697. So that's what you need to find a p-value. Okay. So I'm going to go to Google. I'm going to go past my whole wheat blueberry recipe for muffins, and I'm going to type in z-score to percentile calculator, because we're trying to take that z-score and convert it to a percentile to figure out what that p-value is. The p-value is the area of the tail of our alternative hypothesis. So our z-score is 1.697. If you calculate, I mean, this is the percentage form. It's a right-tailed test, right? Because it said it's that p is greater than 0.5. So it means we're looking for the area that's over here in this tail. And they got 4.48%. So that's 0.0448. What's the conclusion? The p-value is low. They said, where's our alpha? Alpha is 0.01 though. Our p-value is not below alpha. So if the p-value isn't below alpha, we fail to reject it. Okay, I'll make a separate video for this. Oh wait, that was a participation activity. Oh, whoops. I thought I was doing a challenge activity. Okay, so that's 7.1.